Hi, everyone. I'm Marcel Verona, and I am a marketing manager at Move Media. I'd like to welcome you to this session. Please remember that the session is also being recorded and will be available to watch on demand after the session. If you have any questions, please leave them in the Q&A section on the right-hand side of your screen. Your questions will be sent privately. The other attendees won't be able to see them. With that, I would like to introduce our speaker and welcome Robin Schneider from Green Cubes, who will be speaking today about lowering total cost of ownership with lithium-ion batteries and chargers. Welcome.
Thank you so much. I'm really excited to speak to this group today because electrification is a big topic in the industry that Green Cubes works in. I'd like to kind of propose this talk as as overall a case study. I will be going through a specific case study at the end, but in general, this presentation is all about lowering the total cost of ownership of power sources in a warehouse environment. And we can look at the material handling industry as basically a case study for early adoption of lithium-ion batteries and early electrification ahead of other off-road equipment, which is likely going to electrify at a later time period. And there are some reasons that material handling equipment is actually electrifying in advance of the legislation that is coming up from and the incentives that are coming up from the government. And the reason for that is that lithium-ion batteries actually offer improved efficiency and improved total cost of ownership over older battery technology and also over internal combustion engines. So I'm going to go through a brief company intro. I'm going to go over some industry surveys and power trends, and we have the comedy show of my cat in the background for everybody that thinks this is a boring topic. You can watch that. I'll go through some industry surveys and power trends. We'll talk about opportunity charging and what that is and why that's important in the adoption of lithium ion, because a lot of the advantages of lithium ion come from its charging profile. I'll talk about the improved safety and environmental benefits of the types of batteries that we manufacture. And then we'll look at how you can use remote management and the Internet of Things to monitor the batteries and actually understand how they're being used and measure real time the benefits that you're getting in terms of efficiency with these. Finally, I'll go through how we would calculate total cost of ownership and then a specific case study based on a cold storage environment. And cold storage is actually one of the, within this early adoption of lithium ion battery technology, cold storage is one that's actually moving very, very quickly within the last few years. So that's a good example. I'll go over why that is. So Green Cubes designs and manufactures rechargeable lithium-ion battery solutions that are safe and accessible. Our solutions ease the migration away from lead acid, internal combustion engines, and other older technologies that are less environmentally friendly. Our vision is to design platforms to help accelerate the adoption of clean energy mediums. Green Cubes was established in 1986. We have locations in the US, India, Malaysia, Slovakia, Switzerland, and Taiwan. Our manufacturing for material handling lithium-ion batteries is in Kokomo, Indiana, and our engineering design team is in Switzerland. So we have 300 employees and over 100 different power designs over the last decade. We address several different markets, stationary markets like backup power for data, telecom and data centers. We do medical backup power, and then we have material handling and ground support batteries that are very closely related to each other. With all of this, we have designs and manufacturing, and we can monitor all of it remotely to optimize across a global organization. So we offer battery models across all classes of indoor equipment. So for those of you that aren't familiar with the material handling industry, indoor lift trucks or forklifts fall into three categories. There's class 1, which is a classic sit-down type of forklift. Class 2, which is a narrow aisle lift truck like an order picker. And then class 3, which is the like pallet jacks and that sort of thing. So there's quite a variation of battery requirements among all of these different kinds of trucks. So in order to meet those needs, we have 200 different battery models for across all of these classes with the communication protocol that will match the existing truck that usually is running on lead acid. And we also can meet the weight and harness requirements of an existing lead acid battery that's already in the field. So the first thing I'm going to do is look at what's important to this industry. And you'll see that that lithium-ion batteries actually play into what's important today in the material handling industry. So Peerless Research Group, which is the parent company to Modern Material Handling magazine, put out a readership survey in 2021. And they looked at what was important to people who are managing warehouse environments and material handling fleets. And they looked at what is important today and what they view as being important in the future. So I've circled a few of these: safety, cost containment, cycle times and throughput or efficiency, and then environmental sustainability. And these 5 line items are all heavily addressed by improvements in battery technology. And it's interesting that while environmental sustainability is lower down on the list, it is by far the highest growth rate in terms of what people view as going to be important in the future. And if you look at how they're spending their money, we can see that in this same survey, there is a significant portion of spending going to information systems. So I'm going to talk a little bit later about using Internet of Things or smart batteries to get information and how you can use that to optimize a warehouse. So that is related to that. And then you can see there's also a significant portion of funds going to lift trucks within the actual hard equipment. So there's a significant spend in this area. People are, rapidly updating their equipment, and they're moving towards lithium-ion batteries very quickly. So there are 4 different power sources available for material handling equipment. There's the internal combustion engine, which obviously has high maintenance costs, emissions issues. You can't use them inside for the most part, although some people use propane indoors. And then there's sustainability issues. There's the older battery technology of lead acid batteries, which have a low upfront price, but they are really only useful for a single shift. They require regular watering and maintenance and monthly environmental reporting. And then they're a serious cause of workplace injuries. Lithium-ion, on the other hand, is good for multi-shift applications. It's longer runtime, it is a smaller size, it can be fast charged, and it's environmentally friendly. And then we have finally fuel cells or hydrogen power, which is a good option in some material handling applications, but it's a very high capital investment. It does offer the opportunity to do just a 5-minute charge time or fuel exchange, but it does require integration with lithium-ion to be useful. And it's really only appropriate to put in all of this infrastructure if you have an extremely high volume 24/7 operation with like hundreds of forklifts on site. So what we see is right now a very, very rapid change from lead acid to lithium-ion batteries. So why is this? I touched on these earlier, but lead acid requires really regular maintenance, watering and cleaning the acid residue for flooded lead acid batteries. They can only be monitored through a charger interface. They have environmental and recycling issues and government reporting. Workplace issues are really common. So the way a lead acid battery is used if you're using it according to the manufacturer's recommendation, is that you would use it for an 8-hour shift, an 8-hour charge time, and then an 8-hour cooling time. And so if you have multiple shifts, in order to use the same forklift, you would be needing to swap those batteries 3 times in a 24-hour period. And if you don't do that, and you do something called opportunity charging that I'm going to go into in a few minutes, you generally will be damaging the battery. They're low capacity, they're heavy, they're big, and all of these maintenance issues require things like a battery room where they can be maintained and stored and serviced. Those battery rooms require a lot of infrastructure because of the acid spillover. They require a lot of ventilation. They have to have eye wash stations and things like that. Where if we look at lithium ion, it's a very low maintenance option. Basically, once it's installed in the truck, it never needs to come out, and it rarely would need any maintenance. And when you do need to do maintenance on it, it's basically like hooking it up to a laptop and looking at, some kind of software or firmware issue that it may have. You don't have to do actual physical maintenance of it. Lithium-ion batteries have a long cycle life of about 10 years or 3,000 to 5,000 cycles. So basically, you can install the battery in the truck and it'll last the entire lifetime of the truck. Sometimes even longer, actually. We see with like rental fleets that the battery actually needs to go from one truck to another because it's outlasting the truck itself. We currently have many batteries in the field that have been out there for more than 12 years, and we are not getting any of them back. One of the benefits of lithium-ion over lead acid is that it will accept a partial charge without degrading the battery life. So with a lead acid battery, if you're charging always sort of at the top of the charge cycle or at the bottom, that'll damage the battery. With lithium ion, it doesn't matter at all. You can go all the way from top to bottom or hover in the middle and it's all fine. It's worth noting that the definition of cycle life for a lithium ion battery is all the way from full charge to full discharge. And if you do partials, you just add them up to equal a cycle, one cycle. And that the definition of end of life, the capacity of the battery basically tapers off over time. And different manufacturers will define end of life differently, but it's usually about 70% of the initial capacity. So this eliminates battery changes and maintenance and all of the workplace injuries associated with those. So there's, you're not going to drop them on your foot. You're not going to have acid spilling and, splashing in people's eyes. You can get a very long runtime and really tailor it to the utilization. So we typically see a lithium ion battery actually, its defined capacity usually only needs to be about 80% of what the lead acid battery it's replacing, because the runtime is so much better. You actually get full utilization of the capacity. You can do fast charge time. So the battery charges in 1 hour, which means that you can do something called opportunity charging, which is common in high volume material handling equipment. And I'll talk about that in a minute. You can do remote monitoring and troubleshooting because the batteries are connected to the Wi-Fi or the cellular network. They have better cold temperature performance that I'm going to go into in a little bit. And then because of all of these advantages, there's also the potential that you could reduce the number of trucks that are required in the fleet. So because of all of this, there are various research organizations that are looking at the adoption of these different powertrains. But you can see here that lithium-ion forklifts are becoming increasingly common and are likely going to become more common than lead acid in around the 2025-2026 timeframe, where internal combustion engines are going down a little bit, and then fuel cells are getting a little bit of a bump, but they're still really not in the mainstream yet. So it's important to understand opportunity charging and what that is. So basically, opportunity charging is a practice where you charge the batteries during breaks, during lunch, in sort of 15-minute or half-hour increments. And because the lithium-ion battery only has a 1-hour charge time, if you add those up, you basically, in a single shift, you get enough charge time that there's really no downtime at all. So this enables 24/7 usage instead of having a dedicated charge time or doing battery swaps. It also has the advantage that it generally keeps the battery in the middle range, which is an ideal state of charge, and lessens the risk of overcharging or over discharging. And because the battery is always charged, it does prevent unexpected shutdowns. So a lot of the advantage of lithium-ion comes from how it's charged. So this is a charging profile for a lead acid battery versus a lithium-ion battery. And you'll notice they're very, very similar. Basically, you charge at a constant high current for a period of time, and then you allow that current to taper and you hold the battery at a constant voltage. What's important to notice, though, is that for a lithium-ion battery, you charge at a 1C rate, which means you fully charge the battery in an hour. With lead acid batteries, you typically would charge at a C/5 rate, which means you would charge for 5, that constant current portion would take 5 hours. And for lithium-ion, you can do that fast rate up until like 98% of the charge. And then so the taper period is very short, where lead acid, you can only go to about 20%, and then it'll like slow charge the rest of the time. So this is how you can really take advantage of opportunity charging, because with a lead acid battery, you won't get much percent of the charge in like a 15-minute increment. So these are the recommended ways to charge lithium versus lead acid. So with lead acid, you would discharge the battery fully, charge at a C/5 rate. Because the battery will heat up, you ideally would need an 8-hour cool down period. You would also need to equalize the battery on a weekly basis. You can essentially do 1 full charge and 1 discharge per day. And with that, you would get 500 to 1,000 cycles from a flooded lead acid battery. Most people, if they want to do opportunity charging, would charge at a C/4 rate, or we would try to fast charge at a C/2 rate. But it's important to notice that this will shorten the cycle life a lot, like down to 200 cycles or something. And it violates the manufacturer's warranty. So you'd be constantly replacing those lead acid batteries. So there's still a lot of maintenance involved because you're basically using them off label. With lithium ion, it doesn't matter what the state of charge is. You can efficiently charge it. It can be immediately discharged and used. There's no cool down period needed. It'll accept the full charge in a little over an hour. And then you would get like 3,000 cycles to 70 or 80% of the original capacity. And you can do this and still you have a full warranty of the battery. So it's important to also select a charger that is capable of delivering this kind of power to the battery. It doesn't really help you if you've got a battery that can accept really fast charge rates if your charger isn't high efficiency and able to deliver that as well. So Green Cubes actually does manufacture a very small and efficient charger for our lead acid batteries. What you want to look at when you're looking at high efficiency chargers is because you want to do opportunity charging, you want to be able to put that charger wherever it's needed, right? So you don't want to have the operator drive it to a specific room. So you want it like near the bathroom, near the break room. And people and floor space is very important. So you would want to wall mount it, or sometimes people will actually mount the battery up in the rafters of the warehouse. So small size is really important. You want to leverage CAN bus communications to eliminate operator intervention and error. In this case, we actually have chargers that'll charge multiple trucks at a time. So you only need one charger and you can charge up to 3 trucks. It also uses the Internet of Things. You want to look for more than 95% efficiency across the entire power usage. And then for cold storage, you want something that can operate in a cold environment so that you can actually install the charger in the freezer or refrigerator, which minimizes going back and forth out of the freezer. And there are workplace injuries and things associated with that I'm going to touch on in a few minutes. So there's also improved safety with this type of battery. So the maintenance for lead acid batteries is risky, time consuming. Fluid level is extremely important. Overwatering and underwatering can both damage the battery. The batteries contain a liquid electrolyte, which is sulfuric acid and water. The plates in the lead acid battery, if they're not continuously bathed in this electrolyte, will release hydrogen gas during charging. And because of that, you need a lot of ventilation systems. The voltage can actually ignite flammable materials and cause burns. So I know there's always in the news issues with lithium-ion fires, but actually their lead acid fires are very common. People need to wear personal protective equipment, eyewear and gloves, and then you need first aid facilities and eye wash stations and emergency showers and all of that stuff. Lithium-ion, on the other hand, is sophisticated and no maintenance. The cells are sealed. They have safety factors designed into them. Lithium iron phosphate specifically is the safest chemistry on the market with a very long cycle life and a stable chemistry makeup. And I'll talk about that a little bit more in the next slide. The separator in between the anode and the cathode is a major safety factor, and it's been greatly improved in the last 10 years or so. And then the electronics, or the battery management system, provide protection against safety events. They have fuses that protect against over discharge, overcharge, high and low temperature charging, and things like that. And then it's basically maintenance free. So I want to talk a little bit about lithium iron phosphate batteries versus so-called NMC batteries. And I'm sure everyone here has seen in the news issues with mining of cobalt, nickel, and lithium. So in the material handling industry, generally, the manufacturers use what's called lithium iron phosphate, or LFP chemistry. So that's a different cathode material than the NMC that is commonly used in electric vehicles. Lithium iron phosphate has a very good cycle life. It's safer. It burns at a much lower temperature than NMC. So the batteries, if they were to have a thermal event, basically smoke. They don't have any flame associated with them. And because iron is really readily abundant, you don't have as many environmental issues associated with it. The downside of lithium iron phosphate is that it's bigger. So its volumetric energy density is not as good as NMC that's used in laptops and EVs and things. But when you're talking about something like a forklift, it's really not important. So this industry has generally gone with LFP. And we see actually electric vehicles and other off-road equipment likely using LFP in the future also. So with this, you get the better energy absorption, lower electrical costs because of the efficiencies, reduced water consumption, better cycle life, no hazardous spills. LFP is non-toxic and doesn't contain rare metals like cobalt and nickel. It is UL approved, UL and RoHS CE approved. It's easy to dispose of because it doesn't have heavy metals. There's less material scrap and waste because of the increased cycle life and the possibility of reusing the batteries for grid stabilization and things like that. So we actually use Internet of Things to look at how assets are used within the warehouse environment, and we can use that to optimize the battery usage and make sure that we get that we deliver on our promise of an improved total cost of ownership. So I'm going to go over a little bit what that Internet of Things looks like. So we use the remote management to monitor the batteries as part of an intelligent smart system. And that can be shared with the operators and the fleet. You can use it to right size the batteries. You can optimize the capital expenditures, and then you can look at real-time fleet management and optimize operating expenditures as well. So it's pretty simple in concept. What we do is basically look at the batteries, they communicate to a wireless gateway, and then that goes to a customer web portal. And that can be on site, and it could be remote. So we have some customers that are managing like 50 facilities at a time, real time, looking at whether or not they have any issues. Maybe one driver is being less efficient than another, and they can actually look at their utilization. This is what the output looks like from our IoT system. So during trials, we can monitor the performance to verify operator behavior and optimize the purchasing decisions. And then we can do ongoing maintenance and optimization of the battery itself. So you can see on this bottom graph, that's actually a real-time output of the battery being used and charged over the course of a day. So how do we monetize this, or really calculate the total cost of ownership and put some numbers around it? So there are several different factors that go into the return on investment for lithium-ion batteries, and I've touched on these several times, but basically there's operating improvements. So increase in productivity and a lower cost of operation because you don't have to do the battery changes and the maintenance. So that can be about 30%. The utility costs can be lowered by about 20% because lithium-ion batteries are 98% efficient versus 80%. You have improved safety conditions, and that also will help with things like insurance costs. You have improved environmental conditions, so you eliminate the lead from your environmental footprint, better asset utilization. So it's 100% versus needing 3 lead acid batteries per truck, which is a 33% asset utilization, because you have 2 batteries in storage at all time. It also lowers the truck maintenance cost. So this is something I didn't mention, because the discharge profile of a lithium-ion battery is very, very flat, that the voltage is maintained regardless of how much power you're pulling from it. That'll actually cause less wear on the motor. And then there's capital cost avoidance. So you eliminate battery handling rooms. You don't need all of the ventilation. You can eliminate eye wash stations and all of the safety gear. And then you can reallocate that floor space to staging area, whatever, break room, maintenance shop, or whatever. So we actually put all of this into a calculation. And this is just an example. If you have this is an 80 truck fleet in Florida, and we looked at the return on investment or total cost of ownership over a 5-year time period. And you can see that when we plug in all of these different factors, like the capital costs, the estimated life of the truck, the price of the truck, the price of diesel, the cost of electricity, how often the batteries are being used, how many shifts, and all of this stuff, we can actually get a very specific calculation of the total cost of ownership of lithium ion versus flooded lead acid, and also versus propane. So what we see here is about a $4.2 million OpEx reduction for lithium ion over a 5-year period, and about a 2 to 3 million reduction over propane in that 5-year period. And so we can do this very specific calculation, and we do this for our customers, but it's kind of interesting that it's almost not necessary. What we can just kind of use a rule of thumb where if you are using the battery for a full 3 shifts, it's basically going to pay for itself in a 1-year period. 2 shifts, it'll be a 2-year period. And if you're only operating a single shift, it'll pay for itself in about a 3 to 4-year period. So it's basically a linearly inverse relationship to how heavily the battery is used. And so if you have very, very light usage, it will take about 5 years for the lithium ion battery to basically pay for itself. So now I'm going to talk about a case study. I can't name our customer, but this is a major 3PL who was doing opportunity charging with lead acid batteries for a major beverage distributor. So this is a cold storage situation. So these batteries are used in a refrigerator. And like I mentioned earlier, cold storage situations are basically the early adopter of the early adopter. So material handling is moving really fast into using lithium ion batteries for off-road equipment, and refrigerated situations are going even faster. And that's because for a lead acid battery, the electrolyte freezes, and that lowers the usable capacity of the battery. So you can see in this chart on the right, the usable capacity versus the operating temperature. So at like minus 25 C, like a refrigerator, you only get like 50% of the usable capacity. It also permanently damages the battery and shortens the cycle life. The charging time for the lead acid batteries is really long, so you have to take them in and out of the freezer to do the charging. And you significantly underutilize the batteries. And then because the truck is having to go in and out of the freezer, you can actually get condensation that occurs, and that can create ice and dangerous conditions. Where with a lithium ion battery, we actually integrate heaters into the battery so that it's maintained at a safe operating temperature. And it prevents all of this, and you can move the charger into the freezer and just opportunity charge without using extra space. So the advantages of lithium ion and cold storage are integrated heating, keeping the battery at an optimum temperature, intelligent control to make sure that you're not, operating in a situation where it's getting damaged. The charge system can be brought into the cold storage area, so you don't have to do temperature equilibration, no more dangerous condensation, no cold temperature capacity loss, 1 hour fast charging, and it can be operated down to about 40 degrees, minus 40 degrees, I'm sorry, and permanently installed in the battery or in the truck. So with this specific example, we actually replaced 23 electric 500-pound Hyster sit-down counterbalance trucks. It's a classic forklift. We replaced those lead acid batteries that were 48 volts and 850 amp hours with 48 volt 600 amp hour Green Cubes batteries. So you can see that you actually get the same runtime from a 600 amp hour lithium ion battery as you would from an 850 amp hour lead acid battery. And then we use high frequency fast chargers. And this is actual testimonial from this particular customer. So What they identified as the benefits from their point of view is the elimination of battery watering, reduced maintenance cost avoidance of the watering systems, cost avoidance of the acid retention walls and systems, cost avoidance of the eye wash, shower safety equipment, the ventilation system, improved safety for their operators, increased productivity without reduced battery downtime, and better environmental compliance and improvements. The recharge time was improved. So you just need about 1 to 2 hours versus 4 to 6 for their lead acid batteries. You improve productivity because of that, and then you lower the utility costs. And then they also pointed out that the warranty for a lithium-ion battery is significantly better than that for a lead acid battery. So 5-year full warranty for 3,000 cycles, even doing fast charging, where with their lead acid battery, they got a 3-year warranty and 900 to 1,200 cycles. So that summary from that customer, I think, is a really good way to end it, because it basically summarizes all of the points of how you lower total cost of ownership using lithium-ion batteries versus lead acid. And with that, I think we have some time for questions.
Great. Thanks so much, Robin. That was great. Just a few questions for you here. First up, are batteries always a drop-in replacement for lead acid, or are they more designed into the truck?
So the majority of lithium-ion batteries going into material handling equipment today are a drop-in replacement for an existing lead acid battery. However, some of the truck OEMs, Hyster-Yale in particular, have designed trucks that have an integrated battery where the battery is permanently designed into the truck chassis. And when they do that, they are able to take advantage of the smaller size of the lithium-ion battery, and they use that smaller size to improve the operator experience and have the operator have more room within the area that the driver is sitting. So they are able to take advantage of that aspect of lithium-ion, where when you do a drop-in replacement for a lead acid, which is really common, you get all these other benefits, but you don't take advantage of that one.
Great. Next one up, do LFP batteries require rebalancing of the cells as they age?
So each battery is made up of many cells. So it sounds like this person understands that. So there are, each LFP battery has, each LFP cell, I should say, has a voltage of 3.2 volts and a capacity of 105 amp hours. So we use those building blocks to build up to a voltage of 24, 36, 48 volts, and then we build up the capacity to be an equivalent to a lead acid battery. Because we're using many cells, the cells can come out of balance, or basically one of them will charge a little bit more than the other, and you can get voltage mismatches among the different cells. So that is a danger, and the bigger the battery is, the more danger there is of that happening, or the more risk there is of that happening. So so we have in our battery management system and in the intelligence built in to balance the cells. And so that is a requirement for any battery that has many cells. Otherwise, you'll reduce the cycle life pretty significantly because the cells will go out of balance. But we design that into the cell. And so it is similar to NMC.
Great. Next up, is there a solution when the truck can't communicate with CAN for gas gauge? So
yes, each truck OEM has a specific CAN protocol that they use. and the battery can communicate to it, generally speaking, but not always. So in the event that you have a truck that cannot communicate to the battery, we have what's called a BDI, or a battery discharge indicator. That's basically a separate unit that would mount up, where the driver is, that communicates to the battery, so you can gas gauge that way. It's better if it integrates to the truck, but it is acceptable to do it that way.
Great. And I think the last one we'll take here is, what about AMRs and AGVs? What battery technology do they use?
Yeah, so that's an interesting, so AMRs and AGVs are in material handling also. So that's an automated guided vehicle, or an autonomous mobile robot, are those acronyms. So those are also material handling equipment used in a warehouse environment. They're obviously battery operated because they're moving around. And because those are newer technologies, they've generally skipped the lead acid technology and are going straight to lithium ion. They're still a relatively small market as compared to the larger forklifts and pallet jacks and things like that. But they are becoming more common, and they are an adopter of lithium ion. I also see a question about recycling that I'd like to answer, if we have time.
Yeah, we are a little bit ahead of schedule, so yeah, we can fit in a couple more.
Okay. So someone is asking how we're recycling the batteries. So we have a program, we call it our R3 program, where we actually reuse and then recycle the batteries. So we take the batteries back from our customers. I have to admit that this is relatively new for us, because the batteries, people aren't sending them back. We're not needing to recycle them. People are using them. The usable capacity definition of end of life is somewhat arbitrary. And so what we find are people are just continue to use them, even though their usable capacity is getting to 60% or something. So we don't get a lot of batteries back, to be honest. But when we do, we actually take them apart, refurbish the parts that we can, and reuse them. And then we'll, sell the scrap metal and things like that. And then we have a partner who recycles the actual cells. So we don't recycle those, but we have a partner who does, who will basically take the cells and recycle those for us.
Great. Just saw a few others maybe what we should talk about here. So we have a question just asking, can you talk more about replacing the lost weight in the truck when moving from lead acid to lithium ion?
Yeah, so we provide a ballast, basically. So if people aren't familiar, in a forklift, the lead acid battery, because it's so big and heavy, is actually used to counterbalance the whatever weight is on the forks. And so that is necessary for the truck to function. So we actually have, when we're doing a drop-in replacement for lead, we closely match the lithium-ion battery weight to the weight of the lead acid battery within 5 pounds or so. And we do that basically with either, depending on the size that we have to work with, we will use either like a concrete ballast that's distributed around the outside of the battery, or steel, which is obviously more expensive, but doesn't take up as much space. So we have either of those two options that we would use.
Great. And just one more about asking just about storage requirements when not using the lithium-ion batteries.
So ideally, you want to store a lithium-ion battery at about 60% state of charge and room temperature. But they will not be that easily damaged if you vary from that at all. What you don't really want to do is leave it at a completely full charge at like a high temperature. That will affect the capacity somewhat. but not that much. It's not a huge concern.
Okay. I think we've covered them now. Great. So I think we'll wrap up there. Thanks so much for your time, Robin. That was a great presentation. Any last words from you there?
No, I just appreciate the opportunity. I'm really looking forward to some of the other presentations as well, because they kind of closely integrate with this. So I hope everybody found it useful.
Great. So thanks everybody for coming to attend, and please join us in 15 minutes for moving toward greater electrification of off-road equipment. And we'll stop broadcast now. Thank you.
Thank you.